Hi, this is Dr. Morgan. We're going to begin today to go over the Math 1 Semester 1 Practice Final. You can be fully prepared. Remember, each of these questions is exactly like the question on the test, only the numbers have been changed. If you learn how to do each of these problems, you do very well on the test. The first four problems go together. You notice there are four graphs, and you have to match them up. A couple things to notice here, just looking at the graphs. The moment I see a design like that, that's called a parabola. And when I see a parabola, I know that I'm dealing with a quadratic equation. A quadratic equation usually has the form, here's the parent form, of something x squared. The second one has a shape like this, looks like a pyramid. You'll also see it sometimes upside down like that, more common. This is our absolute value. And this usually is designated with the absolute value markers. You'll see two brackets and something inside, absolute value. Number C has a function that is constantly increasing. You'll also see them decreasing. This is the one that's called the exponential. It's designated because the x is actually in the exponent. The last one is simply a straight line. And you'll remember this often by this is called the linear equation. You'll recognize often in the form x plus b. The thing is that the x term doesn't have any exponents or of any kind. Now, given that, we can do our equations pretty good. When we come to number 1, we notice that there's an x in the exponent. That's going to be our exponential function curve. So the answer there is C. Second one, you'll notice it has a square term. That's going to be our quadratic parabola. Next one, or A. Then our next one, x is all by itself without any x squared, cubed, or square root. That's going to be our linear function, number D. And finally, you'll notice here's our brackets for our absolute value. And so that's going to be 4. It's going to be our absolute value bracket. Okay. And so there is our final answers. Problem number 2 asks us to choose the graph that is not a function. One thing about a function is for every x, there's only one y. When you have a graph, what we use is the vertical line test. Draw a vertical line test to see if it ever crosses the graph more than one time. Well, you notice on the first one, A, crosses it twice. We immediately know that is not a function, and that's our answer. But let's go ahead and check the other two just to see how they're doing. Notice I can draw it any place along here. It's only going to cross it one time. One time there, one time there. Likewise, on the next one, again, crosses it one time, and one time. And finally, the last one, our horizontal line, again, no matter where I draw the line, it only crosses it one time. The answer to that one is A. Problem 6, we're asked to look at this graph and answer this question on this study on mice from 0 to 200 days, the population of mice, and find which one is false. We're going to identify each one. First, it says mouse population was at its greatest around day 160. If we draw a line around day 160, we see there's our top. And looking at it in the graph, obviously is the largest one. This one is a true statement. Population B says between 140 and 140, between these 2 days, it was increasing. Well, I notice here and look, yes, it was increasing. That's also a true statement. And then it says there are 2 intervals where it's increasing. Well, I notice that there's another interval here where it's going up, and that's increasing, that's increasing. Apparently, it has 2 intervals. The answer is true. Last one says the least number of mice during the study was 142. Well, if I come over here, erase some of this, and I graph 142, well, it does look like there's a spot right there where it's low. it's the lowest for this, where it dips here. Notice this point here is lower than that point. That makes that false. The answer there is D. On problem 7, Mary is 8 miles from her home. That's where she starts. She's returning home walking at a rate of 2 miles per hour. Distance from home can be modeled as a function of time. Notice we have choices here of how far we're going. Obviously, number of oranges and total cost of dollars has nothing to do with that. So we could write that one out right away. Let's start by identifying the y-intercept. The y-intercept is where the initial value. Where does she start? We said she's 8 miles from home. So B is going to be 8. Let's see which graphs have the point 0, 8. You notice that A does not. A is incorrect. B does not. So again, B is incorrect. But C and D both have a starting value of 8 miles from home. The next thing we have to measure is, how about the slope? Since the distance she is decreasing as she walks home, the rate is negative. We're looking at negative 2 miles per 1 hour. That's the slope we're looking at. And so if we identify these, you'll notice that as we go down here, this one goes down 2 over 1. So the slope here is minus 2 over 1, which is going to be our answer then. On the other hand, the next one here, down 2 over 1, doesn't fit. This one actually goes down 1 over 1. This would be a slope of negative 1 over 1, and that's not our answer. So our correct answer is C. D is incorrect because it has a slope of negative 1, not negative 2. All right. Problem 8, we're looking to see the graph for Jack's earnings. It represents the total amount of money Jack earns during X hours working at $4 an hour. First off, his initial value starts off with $0. As we check along here, we notice that all of these graphs have a 0. That's not going to help us. We're looking then for his slope or his rate, which is $4 an hour. Remember, $4 an hour means from any point it goes up 4 and right 1. Okay. So at this point, notice our slope paragraph of 4 and 1. That one's not going to work for us. Here, this one works. Okay, up 4 over 1, that's good. Next one, C, is 4 over 1, 2 as well. The last one doesn't work, so A and D are out. Now we just have to pick between these two. At this point, we have to look at the viability of the answers. Notice quickly here, B and C are possible answers theoretically, but which one is reasonable? Can Jack earn negative dollars? The answer, of course, is no. As a result of that, this one cannot work. B cannot be right because we can't have Jack working negative hours and getting negative dollars. The answer to this one is C. Number 8, we're just looking for an equivalent expression, not an equation. We're looking to combine terms. Notice initially I can combine the x terms. 7x minus 4x is 3x. I can combine the y terms, or 5y plus 2y is 7y. My answer is 3x plus 7y. And I look up above and there's the answer, 3x plus 7y. Remember, you can only have to have the same variable component to combine them. These are y's, these are x's, and that's why we can combine the coefficients. Problem number 10 is similar to 9. We're looking for identical or similar coefficient. Now, if you notice here, just to point out here, x squared y is not the same as xy squared. So they both have an x and a y and a square. This one has the square root of the x and square root of the y. So they're not similar terms, so we can't combine them. But we do have a 5x squared y and a 3x squared y, so those are exactly the same. We can combine those terms. They, you notice, have the same exact term, so we can say those two can be combined. 5 and 3 is 8x squared y. Nothing combines with minus 4xy squared, so we'll leave that alone. And we'll look up our answer, and there it is, number C, letter C. In this equation, we're given an equation. The distance equals the speed of the train times how fast you were going. And then in the problem, it tells us to find the speed, which is y. Miles per hour when the train departs the station is 357 miles. That's the x. I mean, that's the distance. It's traveled for 7 hours. That's the time. We simply take our equation then and plug in what we know. We know we're going to substitute 357 in for the distance, or y. We're going to put in 7 for the hours, and we have this equation, 357 equals x times 7. So to undo x times 7 here, we're going to divide both sides by 7. 7 divided by 7, remember, is just going to be 1. We're left with x. And 7 goes into 357 51 times, and so our answer is 1. Okay. So the speed of the train is 51 miles per hour. Number 12 is a proportion problem. One method always worked for a proportion problem is simply to cross multiply. Remember, this only works with equations, not with anything, not any other way. So we're going to take ours and we're going to cross multiply. First, y times minus 7. I'm going to write that there, and 28 times 5. Usually we write the variable first, so we'll have minus 7y equals 140. And now to undo, the opposite of multiplying by negative 7 is dividing by negative 7. And then this equals 1, of course. Leaves us with y equals 140 divided by negative 7. So y equals negative 20. So our answer is negative 20. There's an alternative method that you could use if you were looking at it. You could look and say, oh, look, what do I have to multiply negative 7 by to get 48? You say, oh, negative 4. So if I did that and then looked down here and said, okay, what is 5 times negative 4? Well, 5 times negative 4 is negative 20. That's just an alternative way that you can sometimes see in a proportion looking either horizontally or vertically. Number 13 is a basic two-step equation. In two-step equations, we typically undo the addition or subtraction first, and then we undo the multiplication. So my first step is to undo subtract 5. The opposite, the inverse operation of subtracting 5 is adding 5. We must add it to both sides of the equation so that we can keep the equation in balance. So 8x equals 43 plus 5, or 48. Now we'll undo the 8 times x. The opposite of multiplying by 8 is dividing by 8. And you have to do both sides again. And 8 divided by 8 is 1. The way this canceled out. We have just 1x equals 48 divided by 8, so x equals 6. And our answer is C. Is another equation we're going to solve, a little more complicated. But the first thing we always want to do when we're solving an equation, there are no exponents, but we are going to get rid of the property. We need to get the variable out of the parentheses. So we're going to distribute. We're going to distribute now. It's minus 4 times 7 and minus 4 times 6. 22z minus 28z minus 24 equals 8z plus 4. Next, we start looking for like terms on either side of the equation, not across the equation. I notice that I have a z and a z here, so I can combine those two. 22 minus 28 is negative 6z minus 24, 8z plus 4. At this point, we want to get the variable on one side and the numbers on the other. Typically, we could either add 6z to both sides, or we can subtract 8z from both sides. I'm going to add the 6z because I want to keep my z positive. I'm going to add 6z to both sides. We end up, this goes away to 0, and we end up with minus 24 equals 8 plus 6 is 14z plus 4. Now we have a two-step equation. Our first step is undo the addition, so we subtract 4 from both sides. Gets rid of this, and now we have minus 28 equals 14z. We're going to undo the opposite of multiplying by 14, divide by 14. It causes this to become 1z, and we end up with z equals negative 2, and that answer is D. In 15, we're solving an inequality. The only way we solve inequalities exactly the same way we do equations, with one exception. If we ever end up dividing by a negative number or multiplying by a negative number, our sign's going to flip. Let's just see here. If we add or subtract, and just like a two-step equation, we're going to undo plus 3 by subtracting 3 from both sides. That gets us minus 7x plus greater than 21. At this point now, to undo minus 7, we're going to divide by minus 7. Now, notice at this point, we have divided by a negative number. That means that this greater than sign has to turn around and become a less than. So x is less than or equal to minus 3. Okay? The answer is D. Notice the questions they gave you. The answer is, if you chose B, it means that you forgot to turn it around. If you chose A, if you chose C, it was because you forgot to positive divided by negative is a negative. And if you did A, it means you made both of those mistakes. They're giving you a couple opportunities to make a mistake here. Problem 16 is fairly simple. They gave us a formula bx equals 55. They want to know what b is if we plug in x for 9. So let's just do that. For x, put in 9. So I get b times 9 equals 45. Now we solve the equation. We undo b times 9 by dividing by 9. We divide both sides by 9. That becomes a 1. So I'm left with b equals 45 divided by 9, which is simply 5. And so the answer is B. The next problem, we need to sort of solve each equation. And we're looking for the one that's not true. If they're true, we'll end up with a true statement. Let's start here with A. The thing we're going to do is distribute. We get 3 times x and 3 times 1. We get 3x plus 3 equals 3x plus 3. Notice they're exactly the same. Because they're the same, we know that this is not an answer. This is going to be true no matter what we put in there. We could subtract 3 from both sides. We'd end up with a statement. If we subtracted 3x from both sides, we'd get 3 equals 3, which is always true. Let's look at B. Again, we're going to distribute here. So 3x minus 3, don't forget the negative. So bx minus 3x, and then don't forget the negative again. Negative 3 times 2, negative 6x. Now we combine these terms here. 7x, x minus 6 equals x minus 6. And once again, notice identical equations. That's true. So this is not the one that's not true. So let's go on to C. Here we're going to distribute here. Remember that when I go to distribute, this is like I'm multiplying by negative 1. Okay. I'm going to change the sign of everything there. So negative times 3 becomes negative 3. Negative times positive 5 becomes negative 5x. And once again, I have exactly the same equation on both sides. This is not our answer. Obviously, our answer is going to be the last one. And notice when I distribute here, I get 2 times 8 is 16x, and 2 times 5 is 10. Notice the 5 and 5 were the same, but when you distribute, you get 10 and 5, and those are going to be different, so that's never going to be true. And so that's our answer, B. Problem 18, they're asking us to look at a formula and determine what the appropriate unit would be for R. If I take this and I put in its place meters for distance in seconds, notice that I get meters over second. Remember that meters divided by seconds is meters per second. Like miles per hour is you take the miles and you divide by the hour. It's meters per second, and our answer is C. Problem 19 is asking us simply to set up the problem. If I set up, first of all, 35 miles per hour, first thing I like to look at is I set it up as a fraction, a ratio, 35 miles to 1 hour. And so if I want to convert hours to minutes, my question is, I need to get rid of the hours. So if I want to get the hours here, I want to put the hours on top so they cancel out. And so I'm going to be looking for hours, minutes. And how many minutes are in an hour? Well, there's 1 hour in 60 minutes. Okay. So the first conversion is going to be 1 hour, minutes, and so it's going to be 1 hour, 60 minutes. That's my first thing. Second, we're going to convert miles to feet. Well, if I have miles here, then I'm going to want miles on the bottom here. And my feet will be on the top. Okay. I have to ask the question, how many feet are in a mile? And the answer to that is there's 5,280 feet, 1 mile. Now you'll notice here, the answer is up here, 35, 1 hour to 60 minutes, 580 to 280. Here, they have this upside down. Here they got it upside down again, and they have this upside down. And here they did yards instead of minutes. Okay. Notice what happens when you look at dimensional analysis. If you just look at the words, the hours divided by hours go away, the miles divided by miles go away, and you're left with feet per minute, which is the answer that you were looking for, feet per minute. Problem 20 is kind of like the problem we did with the graph where we did the vertical line test. Here we have to remember that for every x, there can only be one y value. So what we're looking for is there an x that ever shows up twice and has a different value. If I look at B, 1 and 3, 1 and 4, and we are looking for the one that cannot be. Notice A, negative 2, 0, 1, 3, 4, there's only one value of x. Likewise in C, 0, 1, 2, 3, 4, no duplication. D, negative 2, negative 1, 0, 1, 2. This is the only one that has 1 times 1 is 3 and 1 times 1 is 4. That means that's the answer that could not be a function. And so our answer is B. In this equation, we have a sequence, and we're looking to see if it's an arithmetic sequence and how we could write it. Remember that in an arithmetic sequence, the nth term equals the first term plus the term number n minus 1 times the common difference. What we need to find is what's the common difference, what's the first term. We can find those two, then we can write the formula. And in our equation here, the first term is 5. That's our first term here. And the difference is, notice that 8 minus 5 is 3. All of them, it's 3, 3, and 3. That's the common difference. So simply plugging this number then into here, and this number into here, we can write our equation. An equals A1, so we put in An equals 5 plus n minus 1 times 3. And we look up and find that that answer is B. Number 22 is a similar problem. It's a sequence again, even though they haven't given it to us. It says the first row of a theater has 20 seats, and then the second row has 23 seats, the third row has 26 seats, and the fourth row has 29. You'll notice immediately that my first term is 20. It goes up by 3 every time. Okay. So in a similar way, in this time, however, they want the recursive formula. Now, the recursive formula is simpler. It just says the nth term is the previous term. N1 minus 1 means whatever term was before. In other words, if you have the sixth term, 6 minus 1 is the fifth term, the one before, plus the common difference. So since D is 3, A1, we don't need an A1 for this one, but we'll find simply plugging in here, we discovered that our equation is AN equals A to the N minus 1 plus 3, and our answer then is B. By the way, to be totally correct, we should have written with this A to the 1 was 20. There are many sequences that just go up by 3. You have to know where your sequence starts. This equation simply asks, the graph represents a solution y equals minus 1/3 x plus 2, and it wants to know how many solutions are there. Well, obviously, in a linear equation, you can find any point on the line. Every point on the line is a solution. If you think about that, here's the point, 0, 2. And if I put 0, 2 into here, I say 2, does that equal 1/3 minus 1/3 times 0 plus 2? That's 0, 2 equals 2, and that is a solution. The same would work for another point here, like this point here is the point 1, 2, 3, and 1. If I put that into there for y is 1, does that equal minus 1/3 times 3 plus 2? Well, minus 1/3 times 3 is negative 1 plus 2, and I get 1 equals 1, and that's also a solution. And you could go along here, and any point along this line, the solution of that equation. In other words, how many points are in a line? Infinite number. The answer to this equation is every point on the line is its solution. There are infinite points, and the answer is E. Problem 24 asks us to graph which graph represents a solution y equals 4x minus 3. This is already in the slope-intercept form, which means we can readily see the slope and the y-intercept. Notice that the slope then is, we're looking for which one has, let's start with the y-intercept. Which one has a y-intercept of minus 3? Come along here, notice A does, B does not. So immediately we know B is not the answer. C has 1, but D does not. So 2 are eliminated. So it has to be A or C. Our next step is to find which one has a slope of 4. And remember, 4 over 1 means up 4 and right 1. If I do my little triangle here, notice here, up 4, 1, 2, 3, 4, and over 1, that is not a solution. But C, up 4 over 1, does land me a spot right there. So the answer is C. C is the graph that matches that. Problem 25, we know that a company makes 4,000 liters of juice per day. That's a rate. And let Y represent the total amount. Y is the total amount in X days. So Y is the amount of juice, X is the days. And if you graph this situation, which values for X and Y will show the points representing the total amount from 0 to 9 days? So this is kind of a domain and a range problem. If X is our days, we have a y-intercept of 0 and a rate of 4,000 liters per day. Our equation is essentially the amount of juice is 4,000 times the number of days. 1 day, 4,000, 2 days, 8,000, 3 days, 12,000, etc. So what is our domain and range going to be? Well, day 1, it's 0. Day 9, we're going to make 9 or 36,000. We're going to go, our X is going to go here, you notice, from 0 to 9, and our Y is going to go from 0 to 3,000. Our domain values are between 0 and 9, and our range values are between 0 and 36,000. So we have to look up and see which one has the answer, and the answer there is B. Notice C just gave us the value for 1 day. A, things around, that number's wrong and got these. It's just different ways you can mess up the problem. Our domain, our X is our domain value, our Y is our range value. Problem 26 is asking us about Pedro. Pedro has $100 saved. Every week, that's what he starts with. That's his initial value. And every week he puts in another $35, so it's going up. The question is, select a quadrant that would allow you to create a graph of Pedro's savings, Y, after X weeks. Okay? So if I have a graph here, notice that quadrant 1 is up here. This is quadrant 1, and then it goes counterclockwise. The numbers are counterclockwise, so they go quadrant 2, quadrant 3, and quadrant 4. When I go to graph it, Pedro starts off with $100. So at 0 weeks, in other words, at 0, this line here represents our weeks. This line here represents our dollars. Starts right there on the line. After 1 week, he's going to add 35. So notice at 1 and then 135. And then after 2 weeks, and you can see where this is going. Each week it's going up. And where are all of his answers? They're all here in quadrant 1. Number of reasons we don't have in quadrant 2, we would have negative weeks. 2 and 3 would be out. And likewise, quadrant 4, we don't have negative dollars. So the answer is A. Number 27 shows us a linear equation written in the point-slope form, meaning it's given us the slope and the x and the y term here. That's the point-slope formula. Okay. The point-slope formula actually, I made a mistake there. And so what we're going to do first here, instead of looking at that, this would tell me that I have a slope of 2. And by the way, that would eliminate these two immediately. We just need to find the y-intercept. To do that, we're going to distribute and solve it. We're going to put it into this form, y equals mx plus b. That will allow us to know what that is. We know what the slope is. It's 2. We're going to find the y-intercept. Let's distribute. We get 2x minus 10. And now we're going to undo the y minus 3 by adding 3 to both sides. And we get y equals 2x minus 7. Once again, our slope is 2, and our y-intercept is minus 7. And so there we have a slope of 2, y-intercept of minus 7. Here's a slope of 2, but they did minus 13. That's what you would have gotten if you subtracted 3 instead of added 3. #28 is a graph problem. It says that coffee costs 250 pounds. And at the beginning, we have initial value. There's no coffee at all. But we're going to pay for it $250 per pound. So X is our pounds. Obviously, the first point 1 will be $2.50. 2 will be $5 if we go up there. So at the next point, so notice all of these have a 0 point. So they're all okay for starting at 0. The rate, the slope is $2.5 per 1 pound. I'm looking for which ones have a slope. Remember, a slope means it goes up 1, 2.5, and over 1. So I move my little graph here. And by the way, up here, my slope, this would be the same as 5 over 2. That's just easier to see here. 5 over 2 is the same as 2.5 over 1. So this one doesn't work, so A is out. B works. That has a 2.5 over 1. C works, and D does not. So we've eliminated A and D, and our choices are B and C. Or just like a previous problem, the question is, they're both possible theoretically, but which one is reasonable? Can you buy negative pounds of coffee? Notice in this one, it goes to negative pounds of coffee here. And the answer, of course, is no. B is not our answer, and the answer is C, the only reasonable answer. Number 29 asks us to set up the equation for the situation. John's going to spend exactly $25. That means that whatever our equation is, it's going to equal 25. It says that candy costs $1.50 each, and candy is X. This is going to be $1.50 times X, whatever he spends. Ice cream is $2.50, and ice cream is Y is the number of ice cream cones. That's going to be $2.50 times Y is how much I spent on ice cream cones. Okay. He's going to spend $25. That's equal. Candy is 150 times X, and ice cream is 250 times Y, and now we have our equation. $25 is going to be however much he spends on candy times 150, however much he spends on ice cream times 250. There's my equation, and I just need to find it up there. It is C. Craig records the number of minutes that it takes him to mow in lawns. So the number of minutes is a function of how many lawns he mows, and he wants to know the average amount of time it takes him to mow his first 4 lawns. 4 lawns, he does 4 lawns in 92 minutes. Well, what's the average? Well, the average, you should simply take the 92 and divide by 4 lawns, and you get that it's 23 minutes per lawn, and the answer is B. Number 31, we're going to find the graph for this equation, y equals 3/4 x plus 1. Notice it's already in the y-intercept form. So we know our slope is going to be 3/4, and our y-intercept is going to be 1. First, let's find out which ones have a slope of 0, 1. A has 0, 1, does not. A is out. B works. C works. And it looks like possibly, I can't tell. D does not look like it works. It's close, but it looks like it's a little above. Okay. Our slope is 3/4. Remember, slope means it's going to go up 3 and right 4. We always go right on the bottom. We use the negative and positive either to go up. If it was negative, we go down. From each of these, we're going to go up 3 and 4 and see which one matches. There, of course, we already decided that one didn't work. Here, B works. C, however, notice here, up 3 or 4 goes over here. This one's actually going up 3 and over 2. This actually, the slope here is 3/2, but it's not what we're looking for, 3/4, so that's wrong. This one here is off as well. Our answer is B has a y-intercept of 1 and a slope of 3 and over 4. Our answer is B. Similar problem here. Notice in this case, it's in the point slope form, which means that the number in front is a slope. If I look here, my slope is going to be 2, and my point is 1 minus 3. Just be careful on this one because notice that this is y minus the number. So here, minus 1, the number is 1. Here, find plus 3, you had to have minus 3, and that's what gave us the minus 3 number. Let's just see which ones have the point 1, 3. 1, 3 is there, but it's not on that line. B, it's not on that line. C, not on that line. It looks like it's on D, so our answer is D. All we had to do in this equation was identify this point. In this problem, they ask us for the x-intercept and the y-intercept. You just have to remember that the x-intercept occurs all along the x-line, y equals 0, and all along the y-line, x equals 0. Our strategy is to plug y equals 0 into here to find the x-intercept, and x into here to find the y-intercept. Okay. So to find the y-intercept, x-intercept, let's let y equals 0. So we have 3x plus 0 equals 15. So that's 3x equals 15. Undo the 3x by dividing by 3, both sides. And we end up with x equals 5. Or the point is 5 with the 0 of y. Find the y-intercept, we let x be 0. So here we put 3 times 0 plus y, that's 0. So y equals 15. Or the point 0 for the x, 15. And now we just got to look up and find the one that has it. And that is the point A. In this problem, they show us the graph of f of x equals absolute value of x. They're basically asking, what happens if you take that equation, you simply subtract 2? What would the graph look like? And if you think about it, all that's going to happen is every point along here is just going to go down 2. Okay? The whole graph is just going to slide down 2 points. This one, by the way, if you actually look at it, is f of x with the x plus 2 inside goes left. This one is where you have the x inside. Notice here it's outside the bars. Inside the bar causes it to go right. This one went up. Okay? This one went left. This one went right. This one went up. The one that went down was here, and our answer is D. Let's graph this problem and then identify the graph on your screen that matches it best. First of all, Scott charges $50 to set it up and then $10 per t-shirt. All right. So I would have a y-intercept of 50, a slope of 10 over 1, and it would look something like that. Here I went up 15 over 5, same kind of thing. And so there's my graph of what Tom's t-shirts look like. Barbara charges 80, but then only 7.5 for t-shirts. So she's going to start higher at 80, then her slope will not be as much. And okay. Number 36. Customer pays C dollars to rent a car for 1 day plus D dollars per mile. What is the equation for the total cost to rent the car? Well, 1 day rental is going to cost is C. That's the cost to rent it for 1 day. He has to pay a mileage fee, so that's going to be extra. And his mileage fee is D dollars per mile. So it's going to be D dollars times the number of miles. 1 mile D, 2 miles 2D. And that adds up to his total cost. My equation then is going to be T equals C plus D. And we just have to find it up here. And it is number C. (37) is a very easy problem. You want to know which one's a likely solution. Well, just plot each point and see on the graph. Now, just remember when you're plotting, the first one is the x, from 0 going x is that way and y is this way. The first one is 0, 3. Not on the line. It's not a solution. Next one is 1, 0. It's going to be right there. It's also not on the line. Finally, minus 1 down 5 is going to be down there. Actually, minus 1 plus 5, sorry. 5, close, but it's not on the line. And finally, we have 5, negative 3, and that's the one that's on the line. That's our solution. 38 gives us a graph of 2 lines intersecting. It wants to find which one is false. So we're going to have to go through and sort through. So f of x equals g of x wherever they cross. You can see that's going to be the point B. So B is a solution. This one's going to be true. That one's not our answer. Point C is the y-intercept. So f of x is here. Where does it cross the y line? Well, this is y. It crosses it here at C. That's what they said. So once again, that's true. And so that's not our answer. Point D, the y-intercept of G. Well, here's G, and the y-intercept is here, right here. It's not D. D is over here. D is actually the x-intercept, not the y-intercept. This one is actually false, and that's going to be our answer. D is the point of the x-intercept, not the d-intercept. So that's going to be actually our answer is going to be C. Last one, A, B, and D in solutions. And to be a solution, any line on the plane, and notice that A, B, and D are all on there. That is a true statement. Our answer is C. Next, we're going to select the graph for the inequality y is greater than 2/3 x minus 2. So first of all, we need to find out what the boundary line is. You find the boundary line by making this 0. That's the line you're going to draw to know whether you shade above or below. In our case, the boundary line has a slope of 2/3 and a y-intercept of 2. Okay. Because it's less greater than, it's a dotted line, and we shade above. So C and D are shaded above. So because these two are shaded below, I know A and B aren't true. They're shaded below. We need to be shading above. Now all we have to decide on C and D is which one is that line. So at this point, y-intercept is 0, minus 2, and so I notice here and here they're both good for the y-intercept. All we have to decide on which one has the slope of 2/3. Notice this one goes up 2 over 3, and remember slope means you go up 2, right 3, whereas this one goes up 2 and over 1. So this is not the right slope. So D is not our answer. The correct answer on that one was C. We're going, on this problem 40, we're going to solve the problem and see if it ever makes an error, or if that's the correct answer. First thing we do here is we're going to distribute. 3 times x plus 3 times 7, 5 times x and 5 times 4. 3 times x, 3x, 3 times 7, 21, 5 times x, 5x, 5 times 4, 20. Second step, let's combine like terms on either side of the equation, but not across. Notice over here on the right side, I have a 20 and a 3 that I can add, and I get 3x plus 21 equals 5x plus 23. And notice, again, at this point, we're correct. What's our next step? Our next step is to combine the terms, and so we're going to get the x's on one side and the y's on the other. So I'm going to subtract first 3x from both sides, and that gets me 21 equals 2x plus 23. All right? And then we're going to subtract 23 from both sides, and we end up with minus 2 equals 2x. If you compare that up here, you'll see that at this point we're wrong. Okay? What happened here is when they combined these, they ended up doing 23 plus 21 over here. That's where they got the 44. So instead of subtracting 23, they added 23. They misdid this problem here. And so our answer is the error there is in step 3. Step 3 is not correct, and the answer is C. #41, they want us to select the correct graph of these two inequalities. First thing I want you to notice is that lines on each of the graphs are exactly the same. It's not about which one graphed correctly. It's all about the shading. We do need to figure out which one is the first equation and which one's the second equation. So 3x plus 2y, the y-intercept is 2, 0, and the x-intercept is 2, 0, the y, 1, 3. That means this line here, on each of them, this is our first equation. Okay? And so in the second one, that means the second one here, notice the y-intercept is 3, 0, and 0, 4. Don't remember how we got that. If you let y be 0, then you get 12, 4x is 3y divided by 4. So that means this is the first equation. This is the second equation. Now, the first equation, it's supposed to be, get rid of these so we can make more sense here. On the first equation, it's a greater than or equal. That means it's going to be shaded above. So if I graph this down here, my first equation is going to be shaded above. That means I'm going to shade above, or if you use the little X trick, an X there and an X there. So on this one, we're going to shade above that line. On the second one, we shade above as well. And our answer is there. Actually, we made a mistake here. Actually, at this point here, the answer is this should be less than or equal. So it means it's going to be, well, what's happening here? It looks like it's greater than, and actually that is correct. And let me explain why. Very common error. I started to make it here. The problem is, when I take this equation here, and I solve it, let me solve it down here. It looks like it's going to be less than. But when I solve it, if I subtract 4x from both sides, I get minus 3y is less than or equal to minus 4x plus 12. Then when I solve here to undo this, I have to divide by minus 3. That gives me this equation, y and 4/3 x and minus 4. The problem is, because I divided by a negative, my sign has to switch around. So that's why this becomes greater than, even though up here it was less than or equal. But in actuality down here, my slide is correct. I'm looking for, on the first one, it's above. On the second one, it's above. And so when you're looking for which one has the two x's or both shades, it's going to be top. My answer to this equation is C. Watch out for that one. And don't just go by here. You have to undo it. If I were to undo this one, for example, this one actually works out to be y is greater than or equal to 3/2 x plus 3. Would have ended up dividing by 2, which would have meant I didn't have to change it. Here we have another set of 2 lines, and they're asking us the false statement. Which one's false? So when x is greater than 3, obviously x equals 3 is an important point here. X equals 3. When it's greater than 3 on this side, is g of x bigger than f of x? Yeah. See, g of x is above. This one would be true. On the other hand, when x is less than 3, on this side, what's true about g of x and f of x? Well, here, g of x, this is g of x. Is it less than f of x? Yeah. F of x is above it. In this case, that one's true as well. Finally, we have f of x is less than, so we're on this side again, less than. You can almost see this is going to be false, because see, when it was less than here, we said it was less than. Well, it can't also be greater than. G is below f. Not going to be greater, so that's our false statement right there. And then finally, g of x equals f of x when x is 3. That's the point right here where they cross. X equals 3. That is a true statement as well. Our answer is C is the false statement. 43, we're looking at each equation and deciding, do they have one solution, no solutions, or infinite solutions? Another way of saying that is, do they cross and have one solution? Are they parallel and have no solutions, they never cross? Or are they the same line, so they have infinite number of solutions? Let's take a look at each equation and just see what we get. On this one, 5x plus 5, if I multiply here, distribute here, I get 5x plus 5 equals 5x plus 5. If I subtract, I end up with a true statement. When does 5 equal 5? All the time. That's infinite. Our statement says that this is true and has infinite solutions. A is a true statement. A is not our false statement. B, I have 3x plus 2 is 3x plus 4. Let's solve this. Subtract 3x and I get 2 equals 4. When does 2 equal 4? Never. This is no solution. As I'm looking up here, it says that this equation is true, has an infinite number of solutions, but we just decided it had no solution. That is our false statement. And that actually is the answer. If we go ahead and do C and D just to check, notice here if I subtract 7x, I get minus 1 equals 3. Never true, so that's no solution. It says here this is not true, no solution, so the statement is true. And finally, D, 4x equals 24. If I divide both sides by 4, that goes to 1. I get x equals 6. There's one solution. It has one solution. So D is true as well. Okay, our answer for 43 was B. Problem 44 has to do with a restaurant serving vegetarian and chicken meals. It tells us on Thursday they made $81. They sold 3 vegetarian meals and 5 chickens. On Friday they got $174. They sold 7 vegetarian and 10 chicken. We want to find out how much is a vegetarian lunch cost. We're going to let V be the number of vegetarian meals and C, and we can write 2 equations. On Thursday, they sold 3 vegetarian and 5 chicken, and they made $81. 3 times the price of vegetarian, 5 times the price of the chicken was $81. On Friday, they sold 7 of these and 10 chicken, and so we have this equation here. And if we solve this equation now, we can find out how much it is. Now, when I look at this, the thing I notice is I'm noticing here a 10 and a 5. If I would just multiply that by -2, this would give me a -10, and I could eliminate my chicken and find out how much my vegetarian is. But when I multiply just that one here, now when I add it, that's 0, and 7 minus 6 is 1, and so the answer is $12. And our last question. Small cell phone has the following charges. 25 cents per minute, gets charged 25 cents per minute of phone use, 15 cents per text. Also, only use 90 minutes of phone per month. And he has a budget of $50. So they want to know which system matches that. Okay. First of all, his phone is 25 cents per minute. That's going to be 25 cents times the number of minutes. And then his text is 15 cents per text, so it's going to be 15 cents times the number of texts. And he has a budget, cannot spend more than $50. Well, more than $50 means he can spend $50, so it's okay to be equal to $50, but it's not okay to spend 51. He can spend 59, which is less than that. And so our answer is that's going to be less than or equal to 50. Spend 50, but no more. All right? Now, what's the other side of this? The other side of this is he can not allowed in his phone plan to ever use more than 90 minutes. So the minutes have to be less than or equal to 9. The same reason he can do 90, but he can't do 91. He has to be less than. Then we identify which one is that, and it is D. All right. I thank you for your help on this. You can always go back and view it again. I hope you do well on your semester final.